In this week's video, we talked about how spacesuits get tested. We talked about Don Pettit, NASA's oldest active astronaut. We talked about new Juno data. We also talked about JWST data being added to a really cool citizen science project. And we talked about budget cuts with NASA and science operations beginning with SpheriX. Hope you enjoy the video. Please like and subscribe if you do. And I will catch you all for the daily videos next week. Have you ever wondered how spacesuits get tested to see if they'll protect the astronauts inside them and withstand the rigors of the harsh environment of space? Obviously, there's a lot that goes into that, but NASA has a cool facility at its Jet Propulsion Laboratory called Citadel, the Cryogenic Ice Testing, Acquisition, Development, and Excavation Laboratory. If that acronym seems like a bit of a stretch, the facility itself is pretty cool. The 4-foot tall and 5-foot diameter chamber uses compressed helium to get down to temperatures of minus 223 Celsius or minus 370 Fahrenheit, and has 4 drawers that are like airlocks, meaning items can be placed into the chamber while it's running and avoid having to warm the whole thing up to make a change. Given that the chamber can take days to reach the lowest temperatures, that's a super handy feature. The chamber has seen tests of gloves and boots, and it contains aluminum blocks that can simulate an astronaut grasping a tool with a gloved hand to see how the fabric and structure of the glove reacts. Mannequin hands and feet with fluid loops to represent blood flow can be put inside gloves or boots during testing to see how they hold up and to get accurate, repeatable measurements. Given that temperatures in the shadowed craters of the moon could reach minus 248 Celsius, this testing is critical for lunar exploration. In the future, the new lunar suits being developed by Axiom Space for the Artemis program will need to be tested, and Citadel will be a big part of that process. You can read more details over at the JPL website, and I'll put a link down in the description. You guys probably haven't noticed this, but I'm not your average 20 or 30-something content creator. As you get older, you start to wonder how capable you might still be, and sometimes write yourself off as over the hill. If you're ever feeling that way, you can take inspiration from Don Pettit, NASA's oldest active astronaut, just returned to Earth from a 7-month stay on the ISS. April 20th, when the capsule touched down, was Pettit's 70th birthday. Pettit was selected as an astronaut candidate by NASA in 1996. In 2002, he had his first adventure in space with a trip to the ISS aboard the Space Shuttle Endeavour. That 7-month stay was extended due to the Columbia shuttle disaster, and Pettit finally got back to Earth on May 4th, 2003. Numerous other Shuttle, ISS, and Soyuz missions have brought Pettit's total time in space to a little over 590 days. He's perhaps best known for his amazing photography during his missions. He was seen looking unwell after landing in Kazakhstan on April the 20th, and he later confirmed that he didn't look well because he didn't feel well after losing his lunch shortly after exiting the Soyuz capsule. The extraordinary Pettit is said to be feeling much better and recovering well as he continues his post-mission rehab that will take about a month. He's also said he would love to get in a couple more missions before hanging up his rocket nozzles. An awesome citizen science project called Galaxy Zoo was launched in 2007. The project has allowed people from all walks of life to look at images of galaxies taken by numerous telescopes and help to classify them. Over 126,000 people have participated over the years, starting originally with Sloan Digital Sky Survey data and including data from space and ground-based telescopes. Yesterday, NASA announced a new reason to jump into this project with the inclusion of James Webb Space Telescope images. JWST has over 500,000 images of galaxies, which is way more than the limited number of scientists can work on. And although Galaxy Zoo's fairly new AI assistant, Zoobot, can be pretty good at classifying galaxies, its work still needs to be checked and confirmed by humans. There are also cases where the image is too complex for Zoobot to figure out what's going on, and a human is needed. In these cases, the galaxy is classified by citizen scientists, that's you, and then the AI can learn what to look for the next time it sees a similar image. Either way, the people involved in the galaxy identification process are providing a huge helping hand in analyzing the galaxy data, almost certainly leading to new discoveries and insights into our universe. On top of that, you could very likely be the first person to ever look at some of the JWST images, and that's an opportunity that doesn't come along very often. Head over to zooniverse.org and take the simple training and get to doing some real science. NASA's Juno mission continues to return amazing data from Jupiter and its moons. Scientists have now combined infrared data from the Jovian Infrared Auroral Mapper, or JIRAM instrument, with observations from Juno's Microwave Radiometer, or MWR, that is designed to look beneath Jupiter's clouds. Not only was this done for Jupiter, but also for its innermost moon, Io. On Io, the scientists discovered something unexpected, evidence that about 10% of Io's surface has still warm magma slowly cooling just below its crust. This data could give new insights into how Io renews its surface so quickly, as well as how heat is transported from the interior to the surface of the moon. Recent GIRAM observations also showed that the most energetic volcano in Io's history, which was first spotted back in December, was still actively ejecting ash and lava as recently as March 2nd. New observations are expected May the 6th, and it'll be interesting to see if the volcano is still active then. Other observations have investigated the cyclones that are found at Jupiter's north polar region. There's one main cyclone right over the pole and 8 smaller ones that encircle it, as you can see in this image. The scientists have developed a new atmospheric model that can explain the observations and may also be able to explain the behavior of cyclones here on Earth. Juno arrived in orbit around Jupiter in 2016 and was originally scheduled to end its primary science mission in 2018 after 37 orbits. NASA extended that mission until September of this year with a further 42 orbits. The ultimate fate of Juno is to burn up in Jupiter's atmosphere. Couple quick space science updates for today on the NASA budget for 2026 and the SPHEREX mission. First up, the White House budget request for NASA for 2026 proposes slashing NASA's funding by 24%, or about $6 billion, which would be the biggest single-year cut to the agency's budget ever. Deep cuts in space science and Earth science will decimate the agency's ability to do basic science and kill Mars sample return and the Artemis program. None of that seems great to me, but it will also have to pass Congress, so we'll see what they have to say about the cuts. For those commenters who always question why I'm bothering to talk about space and science when, in their words, the country is collapsing and the middle class is being decimated, this is why. Without getting into politics or even talking about all the other benefits of funding science, NASA and the other scientific endeavors in the US support thousands of middle-class jobs, and every dollar put into NASA is estimated to generate $3 of economic output, with each NASA job creating 16 more jobs in the wider economy. If that isn't worth promoting and talking about every day, then I don't know what to tell you. If you want to see the study where those numbers come from, there's a link in the description. While we do still have some funding to do science, I'm happy to report the SPHEREX mission started regular science operations on May the 1st after a successful 6-week commissioning phase. SPHEREX will take about 600 images of the sky every day at 6 different wavelengths over the next 2 years to map the 3D positions of hundreds of millions of galaxies. The orbiting observatory will map the entire sky every 6 months, producing 4 all-sky maps over the life of the mission. These maps will give us new insights into the earliest moments of the universe and hopefully unravel some of the mysteries of inflation and other processes that form the universe we observe today.